Hi everyone. In the given problem statement, we have to traverse a binary tree in level order traversal. So we're going to given a root of a binary tree. We have to return the level order traversal of its node from left to right. So let us take this example of this binary tree, which is 3, 9, 20, 15, and 7. So here, right, you have to do a breadth for search. So here, right, we can have a DQ. So let me create this DQ. Initially, it's going to be added with the root node 3. So once the root node is 3, and let's say this would be the current level. So this would be result. So on the first level, right, I'm popping it out, and this is going to get added to this 3 element because this was the single element at the topmost. So now 3, does it have any children? It has 2 children, which is 9 and 20. So 9 and 20 are going to get added out here. Now from this result, right, 9 and 20 are there. So 9 and 20 is going to get added to the result. Now we are popping 9 out. Does 9 have any children? It does not have. Pop 20 out. So 20 has 2 children, which is 15 and 7. So 15 and 7 got added. So 15 and 7 are there in this DQ. So 15 and 7 are going to be added in the result too. And we are popping this out. 15 does not have any children. 7 does not have any children. So it's pretty straightforward. So this is a very straightforward approach. Using just breadth first search, we can easily find the level order traversal. So now let me jump to the Python solution. So the first thing that you're going to do, you're going to import collections. So import collections. So it's going to require for us to create a DQ. So like all the time we are doing, we're checking if our root is empty. So if not root, then we are going to return an empty list. Now we are creating some variable called q, which is going to be collections dot dq, and it's going to have the value of root. Similarly, we are going to have a result, which is where we are going to store the level order traversal values. So while our dq is not empty, we are going to loop it through, and we can create a temporary variable out here to store our values. Now we are looping through it. So for underscore in range 0 to length of our q. Here we are going to say cur equal to q dot pop left, because we're removing the element from the left hand side of our dq. So here temp dot append whatever value that we got, right, we have to add to our temporary list. So it's going to be cur dot val. Now we are going to do two more things. If cur dot left, if it has a left child, right, in that case we are going to add it to our dq. So q dot append cur dot left if cur dot right. So it would be q dot append cur dot right. So that's all. And now for the initial step or the last step, we have to whatever values that is present in our temporary list, we are going to add it to our main result. So res dot append temp, and now we are just going to return our result. So return res. So here, right, if I check for the time complexity, it is going to be big O of n, because we are traversing all the nodes one time. So it's a pretty efficient code. Let me submit for the private test cases. As you could see, it's beating 100% of the submission. So our code is pretty efficient and it's pretty smooth. So now let us move to the next question.